at a couple more reasons why triangles are going to be congruent, or ways that we identify them as congruent. Now, we had already taken a look at side, side, side. We also took a look at side angle side last week. Now, remember, the way the letters are in order is the order that we have to think of them. So when we're dealing with a side, angle, and a side, we need a side, then we need an angle, and then it's side. What makes up that angle? Now, the next postulate that we've got here for this is angle, side, angle. So if two angles and the included side of one triangle are congruent, two angles and their included side, then the triangles are congruent. So I'm going to give you a few moments to make sure that you get that written down. All right, so let's take a look at how this gets done. So, if I want to use this idea of angle, side, angle to justify that these two triangles are congruent, I need to make sure that I have things in the proper order. So, when I look at this, it says that angle A here angle A is the same as angle E. Okay. Then it moves on to tell us that this mark here is the same as this mark over here. And lastly, F is the same as C. So do I have these in the same order, where I have an angle, I have a side, and I have an angle? Now, because I know that the only way for this to be true is that these triangles have to be congruent. There's no other way to do this. Okay? You got to remember, if I'm going to put the triangle together up here, this vertex, and I want this angle to be there, these sides have to be a specific length, and they have to be the same specific length here and here. So let's try this then. And so, what are the measures of the sides? Well, this up here would have to be what? 6. So if I want to go from E to D, that's got to be what? 18. And this side over here has to be 17. Because the angle that goes with this side, the angle that goes with this side is 17. The angle and this side go together, so the angle and this side go together, so it's 18. Just how we can just identify which goes to which. So, try and do a proof of this. I want to prove that triangle SWT. So we have triangle SWT right here is the same as triangle UTV. So I've got UTV. Okay. These two triangles here are supposed to be the same. Now, given that T is the midpoint of WV and VU, or WV, excuse me there, so what does that tell me? T is the midpoint of WV. So does that tell me that this here is congruent to this? And we are told that VU is parallel to WS. One of the ways that I like going through and doing this, before I even try and write out any proof, is what would I be able to identify as being congruent, if anything. Now, whenever we have lines crossed, we got that vertical angles theorem going on. This is one of the things that you should kind of zero in on. If you have lines crossing and a vertical angles theorem, And it looks as though to help us out, if I knew what this angle here was and this angle here would, those would have to be congruent, right? Now, if I am supposed to use angle side angle, I've got my side, this is one of the angles, I got to get this angle here congruent to one of the angles up over here. Now, parallel lines and transversals. This is the next thing you should always take a look at. If you've got anything that says parallel lines, you know that your transversal should be going through them, and you've got your alternate interior angles. Okay? That is going to be a big one that comes up. So I can say that this one here and this one here are going to be congruent. Would that make sense? For now. Sort of kind of makes sense? By alternate interior angles, would that work? So, now I'm going to actually write out the proof. So, we are given that T is the midpoint of WV. So we've got T midpoint of WV. Yeah. And that is just given. That's really the only thing that we're given, right? Oh, we are also given that VU is parallel to WS. Given. So, we're going to go through and do the first thing. First thing we did is we said that these two were the same, correct? So we said that WT is congruent to VT by. What did we use to say that, hey, I know that these two have to be the same? Midpoint. Okay? Definition of midpoint. What was the next thing that we said were the same? We picked out a couple of angles, didn't we? So we said that angle STV or STW is going to be congruent to angle UTV. Why? Yep. Vertical. Here. What was the next thing that we said? Okay, now I'm going to stop you there for a second. The reason why I went STW is because if I said angle T, how many angle T's are there possibly going to be there? 4. How many angle W's are we actually going to have? 1. So when you see that situation that, okay, I got a whole bunch of possibilities here for T, then you got to spell them out. But for this, I can just go and say angle W, because there is only one here that we're working with. One possibility is going to be congruent to angle V. Why? Well, that's AIA theorem, alternate interior angles theorem. Okay. Now, do I have enough to go and say that triangle SWT is congruent to triangle UVT? And the answer is yes. And what do I have to use for it? Angle side. Again, all you are really doing here is saying, hey, this piece is the same as this, and this is why. We make a logical set of arguments and say, this is the same as this is the same as this is the same as this, and because of this, I know these things are the same. That's all that we're really doing here. Simplify it down and don't think into it too much. Like I said, vertical angles theorem, alternate interior angles, midpoint theorem. These things are really going to be coming up quite a bit. Those are the things you need to look for. So, the other one was angle, angle, side. I think I give you moments to go and make sure you get that one right. All right. Now, make sure that you pay attention to the order again. It says if two angles and a non-included side, one triangle are congruent to two angles and corresponding non-included side of another, then the triangles are congruent. So, see what that looks like. They tell us that DE is congruent to LK. So we've got this piece of information here. DE and LK. Those are supposedly the same. Now, they want us to find the area of each triangle. So I need to take a look at this in the order of angle, angle, side. So if I start with angle F, which angle would I have to start with on the other one? No. What would be the next angle that I would want to go through? Because I want to have the angle, then the side. I could go to D. Could I also go to E? But do I have any information about E and K? So if I don't have any information about those, that probably wouldn't be the best way to go, right? I know that F and M are the same. I know that D and L are the same by the mark that we've got here. So now I've got angle, angle, side. Angle, angle, side. Must these triangles be congruent then? According to the rule. So that means that I can now go through and figure out what the area of each one of these things is. So, area is 1/2 base times height. These bases must be equal, so I got 4x minus 2, 3x plus 1. Subtract 3x, subtract 3x, 1, add 2, add 2. So I end up with x is equal to, that disappears, and I get 3. So if x is equal to 3, that means that it's going to be 4 times 3 minus 2, which is 12, minus 2, which is 10. Would you agree? If I went and took it over here as 3 times 3 plus 1, I'd end up with 9 plus 1, 10. So I got it right. It didn't matter which one I used. Just got to pick one. Now again, the algebra that you see here isn't anything spectacular. We've done this all before. Nothing new, nothing scary about it. So, area of the triangle. Base, which is 10, multiplied by the height, which is 6, divided by 2. Right? Boom, 3. So this would have to be 30. But of course I have no idea what this is. We're talking about area, so it's 30 units squared. Make sure that you label it appropriately. Does that make sense? Does that reasoning process seem to be getting a little bit easier as we're looking at these things? Again, there's only certain things that you have to keep in mind. So I keep telling you to write those into your little books so that you can go back to those to help jog your memory. So, let's try this one. I need to do a proof on this one. Now we are told that BD bisects angle ADC. So if it bisects angle ADC, what is that telling me? Cuts it in half, right? So if I go from angle A to D to C, if it cut it in half, does that mean that this angle here is congruent to this angle down over here? Those angles would have to be congruent, right? Because it said that it took ADC, it was bisected, cut right down in half, right down the middle. So those two are the same. Now, it tells us that angle A and C are the same. Now, I get a bit of a problem here because I am supposed to go through and figure out why these two are congruent. I need a side that's congruent, don't I? Do I know a side that's on both triangles that's the same length? BD, yeah, most definitely. When we look at these things in that idea of reflexive, we have to think that BD is a side that is on both triangles. That makes sense to you. And you can cover up the top one and see that, hey, BD makes the triangle down here. Cover up the bottom one. Triangle here. Now, mind you, I did not go through and write anything down for this proof, did I? All I did was took the picture, which you should always draw out, and I put the marks in there so I knew where in the world that I should go with these things. Okay? So now I'm going to start in with the proof. Let's see. We've got angle A is congruent to angle C, and I have, let's see, BD bisects both of those are given, so we just put them all in one line for them. What we did next was we went and said that, hey, angle AEC or angle ADB has to be congruent to angle CDB, right? Why? What did we said something bisected it in half, right? And we said once it was bisected, it got cut in half, right? So we have got one statement that talks about midpoints on a line, on a segment. And now we've got something that talks about bisectors. So we've got two rules here that allow us to cut something in half and say that the pieces are equal. Angle bisector cuts it in half. Two resulting angles are equal. So we can go by the definition of angle bisector. Okay? Now, we did one more thing. We said that DB is congruent to DB. Why? Reflexive. So, do I have enough stuff to say that these two triangles are the same? And the answer is yes. I can say that triangle ABD is congruent to triangle CBD. Why? Because I have one angle, I have another angle, and a side in that particular order. So this turns out to be angle, angle, side. Yeah. Yep. If I learn how to write, that always helps. ABD. Yep. And you get. See, that's one of the things you got to always pay attention to when you're writing things out, because your brain tells you that it's supposed to be A, B, C, D. So. What about this one? It says the diagram gives us a portion of the truss of the new bridge shown. Prove that the triangle ABC, so that triangle ABC is supposed to be congruent to, oops, so this here is supposed to be the same as this here. Now, do I see anything with midpoints? Do I see anything with angle bisectors? Do I see parallel lines? Yep, I do see parallel lines. So what I want to do is I want to try and go through and get things that could be the same here with them. Also, do I have a side that they share in common? Okay. So, as I go through this then, what I'm going to do is I am going to say that, well, would it make sense to say this angle here is congruent to this angle over there? Why? Is that hit with alternate interior angles? Hmm? But they're on different lines. So while I'm sure that those are going to be the same, that probably isn't going to help me out right now. I got to come up with something different. Could I say this one here is congruent to this one here? Okay, that works, right? Because I have got alternate interior angles, correct? Because BD is parallel to this. That's the transversal. Now, can I say that this angle here is the same as this angle down here? And again, yes. I've got my parallel lines for A, B, and C, D, and I have this one line here as the transversal. Okay. Can I now say that this side is the same because of reflexive? So which one did I have information on here? Angle, angle, side, or angle, side, angle? Is the side between the angles. So that means that when I write it out, it would have to be angle, side, angle. Okay, so now, I've just done the writing out here to see which ones are in, and I just got to justify them in my head when I went and did this. So that means that I am going to say that, okay, we've got BD is parallel to AC, and we have AB parallel to CD. And this is given. Then we went and said that angle. And this time, because we got more than one that we could identify, we need to make sure that we identify them correctly. D, B, C is congruent to A, or angle A, C, B. And we said that that was alternate interior angles. We also said that angle A, B, C is congruent to angle D, C, B, again by alternate interior angles, right? We said that BC is congruent to BC because it was reflexive. So, triangle ABC is congruent to triangle DCB by which one do we say? Angle. So, there are just a few things to look for. So, my recommendation for those of you that are awake, when you are going through and doing this, draw out the picture. On the picture, if you can justify it, with an angle, alternate interior angles, angle bisect, midpoints, look for parallel lines. If you can justify it, draw it out and see which ones it is. So, with that thought in mind, I'm going to give you a couple of minutes here, and I want you to go through and do this. we've had a couple of minutes to ponder this. Which one should it be? Got a thought, Ken? Okay, so you say angle, side, angle. Okay, so let's see what I can come up with here. I've got a mark over here, which is the same as a mark over here. This mark goes to this mark. This mark here goes to this mark over here. Okay? Absolutely correct. Angle, side, angle. So then that would imply that this here should be 10, 15, and 11, correct? So, give me another couple of minutes and then I'll let you. All right. Now, what you do is just see if yours followed the same pattern that mine did. So to start off with, I want to prove that the triangles are congruent. So to start with, I want A, B, C, this one here, to be proved congruent to DEC. We were told that AB, so we've got AB is congruent to DE. So A to B, got that identified right there, that's good. So I got a side there. Now we are also told that AB is parallel to DE. So now that I've got that side there, there are a couple of things that I could do. Could I say that angle B and E are the same? Could I also say that angle A and angle D are the same? Okay. So in one way for this one, I could go and say, put it down this way, that this angle is congruent to this angle because of alternate interior angles, right? This angle here and this angle here are congruent for alternate interior angles. So, what we could have is as follows. AB is congruent to DE. AB parallel to DE. Yep. I could go then and say that angle B is congruent to angle E. Why? Alternate interior angles. I could say that angle A is congruent to angle D by alternate interior angles. I could go on to state then that triangle ABC is congruent to triangle DEC by angle, side, angle. Yes? Would that follow? Now what happens if you would have done it this way? What happens if you would have said, this here is congruent to this over here, right? I could have gotten rid of one of these angles or one of these arguments in here and said that angle BCA is going to be congruent to angle ECD by vertical angles theorem. Yes. Is that ever going to be something we ever put down? Why? You got that right. It ain't the right answer. Should this ever be written down? No. So I can tell you right now, you are never, and there isn't one that goes angle, side, side. Evidently my brain was wanting to bring that notion up, but I don't ever usually write it down. We said angle, side, angle, right? There we go. So, yeah, there is no one that there's not one that called side angle or angle side. So now I could say that triangle ABC is congruent to triangle DEC by, this is where the other S came in, angle, side. Now, which way is correct? Yes. Both ways are correct. As I said, there's quite often, there isn't just one way of doing things and getting a correct answer. There are multiple ways of getting at the solution in many cases. But of course, if you don't write it down and show all the work, then you're not going to get anywhere. So, I'm going to give you a couple of minutes and I want you to work on this. So, if two triangles are congruent by angle, side, what is the area of each triangle? First off, just to verify, are these congruent? So now, what's the area? 66. Okay, so let's verify that. So that means we've got to have 4x plus 6 is equal to 2x plus 10. Subtract 2x, subtract 2x, subtract 6, subtract 6. 2x is equal to 4, x is equal to 2, is multiplied by 2 divided by 2. So that means that I am going to get 2 times 2 plus 10. So that would be 4 plus 10, which is 14. Okay. So now, just to double check, 4 times 2 over here plus 6, so to get 8 plus 6, which is also 14. So base times height divided by 2. So base, which is 8, times the height, which is 14, divided by 2, that goes in there for 7. Did you say 56 or 66? 56. 56. Units squared. So, give you some time here and I want you to take notes. All right. We've got to prove them. What do we know? This is always the first step. What do we know? Well, from what I see here, it looks like A and B are the same. Do you agree? Would it appear that this and this are the same? Now, is there any other information that appears that I have? CD. Okay. It appears that CD right here is in common as well, right? So it looks like I've got an angle and a side. So now I've got a good handle to start with. So we can say that angle A is congruent to angle B. Angle CDA is congruent to angle CDB. This was given. Correct? CD is congruent to CD. Why? Reflexive. Triangle ABC is congruent to triangle BDC. The more you work these out, the easier it's going to become. So, here you go.